For the circuit given, we're asked what is the value of the voltage V in units? And then we're given some units that we can use to solve this problem. So when we first look at this, super easy thing to notice is that we are given, we're actually given 4 voltages, right? This is a voltage, it's ground, so it's 0, but it's still a voltage. So knowing that, we are going to use the node voltage method. So when we use the node voltage method, we need to pick a node to look at. I'm going to use this node, specifically because that is what we want to find, our voltage V. And we are going to look at the current flowing out of our node, so the current going this way, and also this way. So let's start with this direction first. Looking at that direction, we first have our voltage minus, and then we have our ground, which is 0. So we're going to have V minus 0, and this is all over our R3, and this because it's ground. Then we are going to add to this the next thing. And so we'll get to this in a second, because we're going to do a little kind of looking at this stuff right here. And so let's look at this part. This is another easy part. We're just going to have our voltage minus our V1, and it's all divided by our R1. Now is where we look at the next part. So inside of here, what we have is the voltage across this part. Now we can see that the voltage right here is facing this way, right? So that means when we have this, the voltage at this node right here, and we'll call this V3, V3 is just going to be equal to our voltage minus our V2. Because whatever voltage is here is going to be this voltage minus this voltage, since it's going in like this. Now, if it were facing, so if we had a plus minus, if it were facing and the voltage was going in this direction, we would just add them together. So this would turn into a plus if it was like this. But it is a minus because the voltage is like this. Now, instead of having some unknown voltage, instead of doing that, we can look at the currents here and here. And the reason why we can do that is because when we use the node voltage method, we're looking at, again, the currents flowing out of our node, like how we have here. So the current flowing out of here is going to be, it's going to have something to do with this and this. We have current flowing this way. And so what we can say is that we know that there is some current, there's some current flowing into this node, right? Well, if this current is flowing into this node, that means it is flowing in and it is minus. Remember, into a node is minus and out of a node is positive. So we're going to have a minus alpha times current. And we're going to have to look at this part as well. We can see that it's going out of our node. And since it's going out of our node, we're just going to have a plus I. And this is all going to just be set equal to 0. Now we can rewrite this a little bit cleaner by factoring out the i's and obviously getting rid of the 0. Now we do have our v, which is what we want to find. We also have I, which is unknown. So let's write something for our I. So our I we'll just do in this color. So to find I, what we're going to say is, well, we know that I has to be equal to, and our I is right here. And so that means that we are going to have some voltage going, or the voltage right here, and we are going to look at the voltage right here. And it's all happening over this resistor right here. So we are always going to have the voltage, so the voltage which is going to be, like we said right here, we're going to have our V minus V2, so we actually are going to be using this, over, again, the resistance that the current is over, which is our R2. And so I, again, the resistance is this R2 because the current is flowing over it. And we have, I forgot what method it's exactly called, but basically you take the voltage going into it, voltage going out of it, and you subtract it, and you get the voltage on top of it, which is going to give you the current. Because remember, voltage over resistance is our current. And so this is what we have now. So we can use this and actually plug this in right here. and right here, or like I said, we can just factor it out. And if we do that, if we replace our voltages, the V's, our unknown V's, with X's, and we plug everything in like this, I've just plugged in all of our values, we're going to get 2.41 as our answer. And again, the Symbol Lab, this is our calculator. This is what we use to plug all of our values in. Now, if we wanted to actually do this by hand, which is good, also a good way to check it, we would, factor out the voltages. We would get everything together, everything that's not a voltage, we would move to the other side and just divide everything that's with the voltage. And this is going to give us the same answer. It should give us 2.41 for these exact values, but if values are different, it's still the same process. So the answer for this problem is going to be 2.41, but more importantly, that is how we would look about solving for this problem.